Good day everyone. In today's video, we are going to talk about chapter 8, which is limits and continuity. Now let's start with 8.1, which is limits. The definition of limits is if the function fx approaches a single number L as x approaches a from either side, then the limit of fx as x approaches a is L, and is written as limit of fx as x approaches a equals to L. Now as you can see, at the bottom of the limit, we can see that x pointing an arrow to A, which means that x is approaching A. But if there's plus sign or negative sign at the top of the A, it means that x approaches A from the right for plus sign and left for negative sign. If there's no sign, which means x is approaching A from both sides. Now let's look into the properties of limits. There are 7 properties here. For the first, second, third, and fourth limits, they are kind of straightforward and easy to remember. But for the fifth, sixth, and seventh properties, they are kind of similar to each other, which involves more than one limits, and they also involve the addition, subtraction, multiplication, and division of limits. And you can actually solve them one by one instead of as a whole equation. Now we'll proceed into the computation of limits. We have few methods here. Now let's start with method 1, which is direct substitution. Limits of a certain function may be evaluated by substituting x equals to a in fx. So simply substitute the x value with a. Now let's look at this example. Limit of 5x as x approaches 3. Just substitute the x with 3 and we'll get 15. As easy as that. So let's proceed to method 2, which is factorization. So limit of a rational function can be found by substitution, but if the value obtained in the end is 0 over 0, which is undefined, the answer is not acceptable. So we must use the factorization method to obtain answer that is not undefined. Now let's look at the example. We know that the equation at the top of the fraction can be simplified. Like, for example, the x squared minus 9 can be written as x minus 3 and x plus 3. Now we can simplify them and we'll left with x plus 3 and substitute the 3, and 3 plus 3 is equals to 6. Rather than we'll get 0. Now for method 3 is the multiplication of conjugates. Same like method 2, it is used when we got the value 0 over 0 when we direct substitute them. So whenever we found a fraction with conjugates, we just multiply, fraction with third, we just multiply it with the conjugate. And the tip here is do not expand the denominator, so we can simplify them and get defined answer. And for the last method is method 4. It is used to find one-sided limit, where a fraction contain absolute value in it. So we know that absolute value have two value, which is positive value and negative value. So in order for us to know which value we should use, is just simply look at the value of a on the bottom of the limit. So for example here, 5 negative. So we'll use negative value and simplify them and we'll get negative 1. So I think that's the end of my part. I'll pass to my bestest of friend, Li. Thank you.
Okay, uh, thank you, Aldrich. So now I'm going to continue with method 5. Okay, method 5 is about test for existence of a limit, where we need to find out, okay, the limit as a process A fx exists or not. So from here you need to find out the value for limit as a process A from left and from right. Both sides you need to find out the value. If the value is the same, that means the limit as a process A fx exists. If not same, doesn't exist. Okay, this is method 5. And the next method, method 6, in infinite limits, where we will get the answer positive infinity or negative infinity. Okay, when we will use the method 6, when we use the method 1, okay, direct substitution, and you realize that it will be a number over 0. Okay, a number over 0, that means we can come out with the answer positive infinity or negative infinity. How? Okay, we just need to substitute the nearest value, okay, the nearest value with the as approaches of a number. For example, x approaches 3. From here, number line come out first. Okay, 3 positive for the right side, negative for the left side, and it's 3 plus. So from here, you can get the nearest value is 3.00001. You substitute this value to the x, and you will get a positive value in your calculator. So it will become positive infinity. Okay, also the same thing for the other side. Okay, so the next method is method 7, is limits at infinity, where our limit is x approaches positive infinity or negative infinity, 1 over x power of n equal to 0, where our n must greater than 0. Okay, for example, 3 over x power of 5. Okay, maybe 4 uh, over x power of 1. Okay, all of this will be equal to 0. This is method 7. Okay, and method 8, the last method for limit, is limits at infinity for rational function, where our limit as approaches positive infinity or negative infinity. If we direct substitution, we will get infinity over infinity. So in this situation, we need to divide each term by x to the highest power of the denominator to find out the answer. Okay, that's all from me. Thank you. I'm going to pass my turn to Nadzir to continue with the subtopic continuity. Thank you.
So thank you to Ling for explaining the method 5 to 8. I'm going to continue with another two subtopic. First one is 8.2 asymptote. So we have vertical asymptote and horizontal asymptote. Starting with the vertical asymptote. Okay, so we have a line x equal to a is a vertical asymptote of the function if either the limit x approaching the value of a from the right and limit x approaching the value of a from the left of the function is equal to positive or negative infinity. So step to find the vertical asymptote is, first one, we will need to make sure we find the value of x that will make the denominator equal to 0. In this case, we will have x equal to negative 2, in which it will make the denominator of both sides to be 0. So we use method 6 explained just now by Ling. That is, we sub with the nearest value of the x using the number line method, and we will get the limit from the left and the right to be equal to negative infinity and positive infinity. Hence, we will conclude that x equal to negative 2 is the vertical asymptote. Moving on with the horizontal asymptote. So we know that line y equal to b is a horizontal asymptote of the function if either the limit x approaching the positive infinity and limit x approaching negative infinity of the function is equal to the same value that is represented by b. So steps to find the horizontal asymptote is we need to use the method 7 and 8. So just like how explained just now, when we have the function, we can use the method 8 to factorize it by the highest degree, and then from the method 7 we know that any value over x to the power of n would always be equal to 0. Hence, once we uh, get the limit x approaching positive infinity and negative infinity to be equal to the same value, that is 1 or b, we can know that the value of b or y equal to 1 is the horizontal asymptote. Moving on to the last subtopic at point 3, continuity. Continuous function is a function y equal to fx that can be graphed through its domain without lifting the pen. So the requirement of continuous function is first, fc is defined. Second is the limit x approaching the value of c of the function should exist. And then we can make the conclusion that limit x approaching c of the function is equal to the fc. So the continuity test, we can know that the point x equal to c, we should determine whether fc is defined or not. If it's not defined, we can conclude that the function is not continuous at the value x equal to c. However, when it is defined, okay, so we can continue with finding the limit x approaching the value of c from right and from left of the function. And we get the same value that is represented by m here. We can conclude that limit of x approaching the value of c of the function should exist. Hence, the conclusion here is that the limit x approaching the value of c of the function is equal to fc, and the answer will be the function is continuous at x equal to c given here. However, take note that if the limit x approaching the value of c of the function is not equal to fc, then the function is not continuous at the value of x equal to c. So that is all. That is the wrap of our presentation video on mind mapping of chapter 8 limits and continuity. Thank you and bye.